Hello dear friends, I am Rahul Gawande. In this video we are going to study chapter number 2, quadratic equations of Maths 1 of standard 10. Now quadratic equation, which equation is called quadratic equation? In chapter 1 we studied linear equation in two variables, linear equation in two variables. Here we have to study quadratic equation. Now that type is based on its degree. Now linear equation in one variable, you know. Linear equation in one variable. Standard form of linear equation in one variable is ax. Now here ax, x variable, plus b is equal to 0. Okay, ax plus b is equal to 0. Now here what is variable? X. X is variable, right? A and b are real numbers. Their condition is that a does not equal to 0. A should not be equal to 0. Now here what is index of each term you see, means of the variable, index of the variable, not of constant number. Now here variable is x. What is index of this? Here is 1. Now as here index is 1, it is linear equation. And what is the variable? X, only 1. That's why it is one variable. Okay, it depends on this degree. If it is called degree now. If degree is 1, then it is called linear. Okay, degree 1, that's why linear equation. It is called linear equation in one variable. Now in this chapter, the name of the chapter is quadratic equation. We are going to study here quadratic equation. Okay, now quadratic, what change will be there? Standard form of quadratic equation is that ax square plus bx plus c is equal to 0. It is the standard form of quadratic equation. You remember this, ax square plus bx plus c is equal to 0. Now see the indices. Here index of this constant 0. Here index 1. Here index 2. What is highest index? 2. Highest index is called degree. Now here degree is 2. Degree is 2, and that's why it is called quadratic equation. It depends on degree. If their degree is 1, we call that equation linear equation. If degree is 2, means highest index is 2, that equation is called quadratic equation. Now in this chapter we are going to study about quadratic equation. Let's start practice at 2.1. First question is write any two quadratic equations. This example is open-ended example. It means that every one of your answer will be different. We have to write that in standard form. Now standard form we know. Standard form of quadratic equation is ax square plus bx plus c is equal to 0 is the standard form or general form of quadratic equation. Okay, now here just you have to replace values of a, b, c only. X keep constant because that is the variable. If you change a, b, c, and it is open ended. Okay, now if I want to write, I can write any number. If you want to change, you can change. Now I write it as 2x square plus 3x plus 4 is equal to 0. It is said that any two. Okay, any two. We can write a lot of infinite equations. Second equation I can write as any number I can put here. 3, 7x square. If you want to change variable, you can. Okay, variable you can change here. Now I write here y. It is standard form only. Here variable we can change. 7y square minus we can write here 5y plus 3 is equal to 0. By any way you can write, okay, but that is a variable, maybe a single. Two variables don't write there, x, y both together, then that will not be quadratic equation in one variable. Okay, now any two I wrote like this. If you want to change, you can change their integers, their numbers, this 1 2 3, these numbers you can change. Condition is here that a and b should not be 0. A does not equal to 0 and b also does not equal to 0. These values you cannot put 0. Except 0 you can write any number in place of ABC. Now let's see example number 2. Decide which of the following are quadratic equations. We have to find out, we have to write that given equation is quadratic or not. For that we want two conditions. First condition is that there should be only one variable, and second, degree should be 2, its highest index should be 2. Now see here, x square plus 5x minus 2 is equal to 0. Now in this equation, highest index means degree is 2, highest index is 2 and variable is only x. That's why, is it quadratic? Answer is yes. If we can write here, in equation ax square plus 5x minus 2 is equal to 0. What is highest index? Maximum index is 2 and variable is x. X is the only variable. This is the reason. X is the only variable and highest index is 2. Highest index is 2. Therefore, it is quadratic. With reason we have to write, and reason is here, x is the only variable, highest index is 2, therefore it is quadratic. Okay, now example number 2. Now example number 2, you to see here, example number 2. In equation, now it is not standard form. You can write, if you want, you can write in standard form. Standard form we write like this, y square, bring these terms to left side, minus 5y, sign will change, plus 10 is equal to 0. It is standard form now. What is the variable? Y is the only variable. Y is the only variable. And what is highest index? Highest index is 2. Highest index is 2. Therefore, is it quadratic or not? Then yes, it is quadratic. It is the answer. Yes or no, decide. Okay, but with reason. Now example number 3. Y square plus 1 upon y is equal to 2. Now it is not in standard form. We don't want any variable in the denominator. If any variable is given in the denominator, you multiply by that to all terms. Therefore, multiply by y to all terms here. Then y square plus 1 upon y is equal to 2. Or first I bring this 2 here, minus 2 is equal to 0. Now multiply by y to all terms. Multiply by y to all. Multiply by y here, it becomes y cube. Plus if you multiply by y here, y will cancel, 1 only. And if you multiply by y, it is 2y is equal to 0. Now identify, check is it quadratic or not. For quadratic we want highest index is 2. And what is highest index here? 3. Therefore we can write here highest index is not 2. Highest index is not 2. Therefore it is not quadratic. It is not quadratic. Okay, in this way we have to write reason also. Same way fourth. Here also x plus 1 upon x, bring this minus 2 here, plus 2 is equal to 0. Now multiply by x to all. Multiply by x. Then we get x square plus, here x will cancel, only 1, plus multiply by x here, 2x is equal to 0. No need to write in standard form. If you write, it's okay, but it is not said write in standard form. Therefore, for identification, if you don't write, then also no problem. What is highest index here? 2. Correct, no? Highest index is here 2. That's why is it? Then answer is yes. here we have to write highest index is 2. Highest index or maximum index is 2. Therefore, it is quadratic. With reason we have to write always. This is example number 4. Now fifth example from this question. Here are two brackets. We have to solve it. M plus 2, m minus 5 is equal to 0. Now you can multiply term by term, or otherwise if you know how to write direct expansion of this, that also okay. Now here m is common term, these two are uncommon, therefore we can directly write is expansion. How to write? Common term square. What is common term? M square, then square of common term. Okay, now subtraction or addition of unlike means uncommon, non-common, these two are, and what is subtraction of these two? Minus 3, then m again common, and product of uncommon minus 10 is equal to 0. It is the expansion of this, directly we wrote. Now see here we can write now highest index is 2. Highest index is 2 and m is the only variable. Therefore, it is quadratic equation. Okay, fifth. Sixth, now here and here some terms are there, we will write them in standard form. For that I write first as it is 3m square minus 2 is equal to 3m square. Now what? See here is 3, here is 1. Transfer all these numbers there, terms there, and then exchange side. Then we can write it as 3m square, sorry, cube is here, 3m cube, then transfer this there, minus m cube minus 3m square plus 2 is equal to 0. Now 3m square minus m square, 2m cube minus 3m square plus 2 is equal to 0. And now check here, highest index is not 2. What is highest index here? 3, means is not 2. Therefore, it is not quadratic equation. In this way we can identify that given equation is quadratic or not. Dear friends, question number 3 now. Here write the following equations in the form ax square plus bx plus c is equal to 0 in standard form. We have to convert given equation in standard form and then write the values of a, b, c for each equation. Means by comparing with standard form we have to write a, b, c values. But before that we have to convert this in standard form. Now I write first as it is 2y is equal to 10 minus y square. Standard form is equal to 0 form. Okay, if any term or if some terms are on the right side, you bring them on left and is equal to 0 on right side. Okay, now here are two terms on the right side, transfer them on left, then is equal to 0. Here minus y square, it will be plus y square. Then I write this plus 2y as it is in standard form, and this minus 10 is equal to 0. See here, it is now standard form. Write the following equation in standard form we wrote. Now we want ABC values. For that we have to compare. Comparing with standard form. What is standard form? Here variable is y. Therefore ay square plus by plus c is equal to 0. We get, now comparing with standard form, we get three values. A is equal to coefficient of y square. A is equal to 1 now. B coefficient of y. B is equal to, here you see, coefficient of y 2 with sign. And c value means constant, last c is equal to constant with sign minus 10. In this way we got, by comparing with standard form, ABC values a1, b is equal to 2, c is equal to minus 10. Let's see example number 2 here. Now here solution, I write again x minus 1 bracket square is equal to 2x plus 3. First expand this bracket, x minus 1 bracket square formula you have to write here. Okay, now here x square minus 2 into a into b means 2x plus 1 square of second 1 is equal to 2x plus 3. Now bring these two terms here on left. X square minus 2x, this plus 2x, sign is change, plus 1, and this minus plus 3 will become minus 3 is equal to 0. Now like terms you do their addition subtraction of like terms. Minus 2 minus 4x, here minus 2 plus 1 minus 3 minus 2 is equal to 0. See, it is standard form now in the variable x. Comparing with standard form now, comparing with variable x, ax square plus bx plus c is equal to 0. Comparing with this, we get three values. We get a is equal to coefficient of x square means 1, b coefficient of x with sign minus 4, and c coefficient means last constant minus 2. In this way we get here ABC values comparing with standard form of quadratic equation. Now third example from this question. Write in standard form, then compare with standard form, find ABC. Okay, now here is bracket, out of bracket minus, and we have to bring them here now. X square plus 5x is equal to minus, I write first as it is because it is the solution. X square plus 5x, now remove bracket, sign out of here out of bracket is minus, then minus 3 minus plus x. Now bring these terms here. X square plus 5x minus x plus 3 is equal to 0. X square plus 4x plus 3 is equal to 0. It is standard form. Now compare with standard form now. Comparing with ax square plus bx plus c is equal to 0, we get ABC values. A is equal to coefficient of x square 1, b is equal to coefficient of x 4 here, and c is constant, means c is constant 3. In this way we wrote here in standard form, and here by comparing with standard form we got ABC values. Let's see example number 4. 3m square is equal to 2m square minus 9. Now here is m square, here is also m square. 3m square, bring these terms here on left, minus 2m square plus 9 is equal to 0. Now 3m square minus 2m square, m square plus 9 is equal to 0. But is it in standard form? For standard form we want three terms. Therefore write this as m square. Now middle term is missing here, then I write as 0m plus 9 is equal to 0. See, this is standard form, m square plus 0m plus 9. If any term is missing except square, then you can write 0 there. Comparing with standard form now. Comparing with am square plus bm plus c is equal to 0, we get, now a is equal to m means 1, coefficient of m square 1, b is equal to coefficient of m here 0, and c is equal to constant is 9. In this way we can find. Now fifth example from this question. P in bracket 3 plus 6p is equal to minus 5. Now solve here. Multiply by p to this bracket. P into 3, 3p plus p into 6p, 6p square is equal to minus 5. Then write in standard form. 6p square first I write, then 3p, and this minus 5 will become plus 5 is equal to 0. It is standard form now. Comparing with standard form. What is standard form in p now? AP square plus BP plus C is equal to 0. We get A is equal to, now coefficient of p square is A means 6 B is equal to coefficient of P here 3, C is equal to coefficient last 5. These are ABC values, A6, B3 and C5. Now 6th example from this question. X square minus 9 is equal to 13. X square minus 9 minus 13 is equal to 0. X square here minus 9 minus 13 will be minus 22 is equal to 0. Okay, but not in standard form, no, middle term is missing, therefore we can write here that is x square plus 0x minus 22 is equal to 0. Now comparing with standard form, ax square plus bx plus c is equal to 0. We get ABC values now. A is equal to 1, B is equal to 0 here middle, and C is equal to minus 22. Okay, in this way we can find ABC values comparing with standard form. Dear friends, let's see question number 4. Determine whether the values given against each of the quadratic equation are the roots of equation. Now here equation is given, it is quadratic equation, and here some values are, two values are given of x. We have to determine that these values are roots or not. How to identify? We have to put value of x is equal to this number in the equation, and if we get both sides equal, then that is the root. If we don't get both sides equal, then that is not root. It is very easy. Let's see now. Now here first value I put here x is equal to 1. Check for x is equal to 1. Then I write here, put x is equal to 1 in left hand side of the equation. Okay, only left hand side of equation. Don't write the whole equation, write only LHS because we are going to determine. Then I write LHS. Left hand side is equal to only left hand side this x square plus 4x minus 5, and now put here x is equal to 1. Put x is equal to 1 in LHS. Then x is 1 now, 1 square plus 4 multiplied by 1 minus 5. Now solve this. 1 square 1 plus 4 ones are 4 minus 5 is equal to, now add it, 4 1 plus 4 5, 5 minus 5 0, and see now what is right hand side here, right side of equation 0, and it is RHS. Here we solved LHS, we got RHS, both equal, and if you get both equal, LHS is equal to RHS, then we can write therefore x is equal to 1 is the root of equation. Which equation? This given equation. Okay, is it easy, no? Same way check for minus 1. Here one more value is given there, then this is second part. Here first part you can write here 1. Number 2, same method. Put x is equal to minus 1 in left hand side. In left hand side we have to find, because we are going to determine. Okay, now LHS is equal to, again I write LHS, same steps, x square plus 4x minus 5. Okay, same LHS here, and let's see what do we get on right side. Is equal to, now x is equal to minus 1, we have to put minus 1 bracket square plus 4 multiplied by minus 1 minus 5. Minus 1 square 1, square of minus 1 1, plus minus minus, 4 ones are 4, and this minus 5. Now see what do we get here, 1 minus 4 minus 3 minus 3 minus 5 minus 8. Do we get 0 here? No, it is not equal to 0. Therefore here LHS is not equal to RHS. We did not get LHS RHS equal, and if both sides are not equal, then we have to write here x is equal to minus 1 is not the root of equation. Okay, in this way we have to determine. Now let's continue second example from this question. Now here LHS and here 0, two values are there. First part, put m is equal to 2, first this m is equal to 2 in left hand side. Now I write here left hand side of this equation, 2m square minus 5m. Put value of m 2 first, 2 multiplied by here 2 square minus 5 multiplied by 2. Okay, wherever m is there put 2. 2 multiplied by 2 2s are 4 minus 5 2s are 10, 4 2s are 8, 8 minus 10, 8 minus 10 minus 2 and not equal to 0. See here RHS is 0 and we don't get 0, therefore we write here LHS is not equal to RHS because our RHS is 0 and we got minus 2, and therefore here m is equal to 2 is not the root of equation. Okay, first value for first value. Now second value, second, put m is equal to 5 upon 2 in LHS. If it is question is like this, determine, you put in LHS. Okay, now again I write LHS, left hand side. Left hand side is 2m square minus 5m. Now let's put m is equal to 5 upon 2, 2 multiplied by 5 upon 2 bracket square minus 5 multiplied by 5 upon 2. Let's solve this. 2 multiplied by square of 5 upon 2, 25 upon 4. Here minus 5 5s are 25 upon 2 is equal to, here reduction we can do, 2 1s are 2 2s are, then 25 upon 2 minus 25 upon 2. Now what do we get? 25 upon 2 minus 25 upon 2, 0, and it is RHS. Therefore LHS is equal to RHS. And if we get LHS RHS equal, then we can write here m is equal to 5 upon 2 is the root of equation. Okay, in this way you remember that if question is determined, then you have to put given value in LHS. Dear friends, let's see example number 5 of practice set 2.1. Find k if x is equal to 3 is the root of this equation. Now it is not given determine, it is not given as it is determined is it or not. It is given that it is the root of equation. If x is equal to 3 is the root, means we can put x is equal to 3, then we get 0. We are not going to determine, it is given, means put here x is equal to 3 in that equation. Already right left sides are equal if that is root. Then what to do? We have to find k value. It is very easy. Write equation first as it is, kx square minus 10x plus 3 is equal to 0. Okay, now here what is value of x? 3. Now put x is equal to 3, k multiplied by 3 square minus 10 multiplied by 3 here again plus 3 is equal to 0. K multiplied by square of 3 9, k will be as it is because we have to find k value, minus here first product 10 3s are 30 plus 3 is equal to 0. Now k9 means 9k, and here minus 30 plus 3 minus 27 is equal to 0, right? Now by transfer order, 9k is equal to 27 minus 27 is transferred there, k is equal to 27 divided by 9, and k is equal to, by reduction 9 3s are 27. In this way we got here k value. Okay, it is not said here determine, it is given here it is the root. If it is the root, by putting this value we get both sides equal. Okay, and if it is given determine, then you put in LHS. If you want to find the value of k, if it is the root, then write equation, then you don't write only LHS, then write equation. Okay, let's continue next example. Dear friends, now last example number 6 from this practice set 2.1. It is activity based example and it is very easy. One of the roots of equation 5m square plus 2m plus k is equal to 0 is minus 7 upon 5, means it is the root. Okay, we are not going to determine, it is the root already given. Complete the following activity and to find the value of k. Now here activity, dash is the root. What is the root given here? This one. Then I write here minus 7 upon 5 is the root of this equation. Then put this value in equation. Put m is equal to what now? Again minus 7 upon 5. We have to put m is equal to minus 7 upon 5 in the equation. Now right here, equation is here 5. M square here means minus 7 upon 5 bracket square. Okay, minus 7 upon 5 bracket square plus again m is minus 7 upon 5. Minus 7 upon 5 plus k is equal to 0. Now we have to write directly now here by solving. Here 5 we cannot cancel. First square. Okay, now I explain you here 5 multiplied by, what is square of this? 49 upon 25. Okay, here. Now here plus minus will be there, but here is plus given, that's why plus. Product of this 7 2s are 14 upon 5 minus, okay, in bracket, plus k is equal to 0. We want direct answer. Now here 5 1s are 5 5s are, then here we get 25 upon 5, 29 upon 5, okay, here. Then plus sign is here, that's why plus 14 upon 5 plus k is equal to 0. Now see what is first bracket? First bracket is this 49 upon 5 plus what is second bracket? Second bracket is this 14 upon 5. Second bracket is equal to this. Now we have to solve this. It will come here 5 5 same base, then addition of these two numbers 40 50 63 upon 5. Okay, 63 upon 5, and by transfer order it becomes minus 63 upon 5. In this way we got value. It is not reducible, that's why we have to write as it is. Then k value we got minus 63 upon 5.